of you have, probably all of you, I'm sure, unless you've never drinking anything but water your entire life, you have drank a solution. Okay, so this is very common. Some reason for students, they, chemistry seems like, just this way off subject that we don't interact with every day, but you do. You interact with chemistry every day. So a solution is a mixture of two or more substances, and they are dissolved in each other. Okay, so you've made solutions in the lab, plenty of solutions. Just about everything you've worked with besides the deionized water has been a solution. Okay, the solute is the substance that's present in the smaller amount. Okay, it's what's being dissolved. Okay, the solvent is the substance present in the larger amount. Okay, and most times, at any time in this class, water is one of the most common solvents. Okay, so it's what we call an aqueous solvent or an aqueous solution is when you use water as your solvent. Okay, so the solvent is what's present in the most amount. Okay. If we think about even just a salt solution, so you all made a salt solution your first lab. Okay, and so you put, I think, about 10 grams of salt into a beaker, then you added so much water. Okay, so is the salt your solute or your solvent? Was the salt your solute or your solvent? Okay, I heard somebody say solute. Do you agree with that? Yes or no? Yeah. Okay, it was present in the smallest amount. A lot of times, it doesn't have to be a solid. It could be another liquid present in the smallest amount. Okay, but the salt was what was being dissolved, right? Because then you stirred it around and you dissolved the salt. Okay, so the solute was the salt, and then the water was the solvent. Another thing that you've all come in contact with and may not have thought about it was you've been able to, or you've talked about or expressed the concentration of a solution. Okay, so how many of you have drank, maybe a sweet tea and been like, "Ooh, that's too sweet"? Okay, then you've been in contact with something that was highly concentrated. Okay, so what we're going to do in chemistry is we're going to take these terms and put them into more technical terms of how do we express concentration. Okay, so if we'll just use the sweet tea example. So if I have a sweet tea that's way too sweet, so I'm at some restaurant or whatever, okay, what could I do to it to get it just a little bit more, get it less sweet so that I could be able to drink it? What could I do to it? Okay, well, if I put more tea and it's really sweet, then, yeah. Okay, you could add unsweet. Yeah, my dad does all the time. He does half and half. Okay, or you could add water, right? So what is that called when you add water to something and you dilute it? Exactly. So that's another thing that we're going to talk about today. So most all of you have diluted something, whether it's in the kitchen or, whatever you've been in contact with. So we're going to talk about the ways that we can express concentration. So in chemistry, just like when you say I have 10.0 grams of salt or whatever the chemical is, we have to do the same for a solution. We have to know how concentrated it is. Okay? This is very important because if we have, hydrochloric acid, it's a strong acid. Okay, if I set that out for you all to use at that strength, we're going to talk about what the technical term is, I almost used it there. Okay, the strength of it is very important. So there are reactions that won't work unless they're at a certain concentration, okay, especially when you have solutions. Okay, if I set out a bottle of concentrated, the highest concentrated you can get of HCl, okay, then that, number one, is not very safe for you all. Okay, so this is what we spend a lot of our time doing, is taking that concentrated HCl and diluting it so that it is less concentrated. Okay, and so we'll tell you this is 1 molar, okay, molarity, that's what we're going to learn today, concentrated HCl. Okay, so we've diluted these so that you guys are in contact with very strong acids or bases or anything like that. Okay, so one common unit of concentration is percent by mass. Okay, so first off, the name tells us this is going to be a percentage, and it's going to be based on mass, right? Okay, so what's our unit for mass that we've been using? Grams, okay? And I've told you when we have a percentage, you always want to think of part over whole times 100, right? Okay, so that's what you're going to do here. So here, it says that we're going to take the mass of the solute. Okay, that's what's present in the smallest amount, so that's the part, right? Divided by the mass, the total mass of the solution, okay, times 100. And this gives us a percentage, so I could say this is 5% by mass sodium hydroxide, or HCl. Okay, so this is one of the most common ways that we express concentration. Okay, so here's an example. Here's our salt solution again. We have 25 grams of sodium chloride, okay, and then we take 87 grams of water. So more than likely we would have had to take our graduated cylinder, put it on the balance, tear it out, and then add 87 grams of water. Okay, or you could do the volume and use density and calculate the mass. Okay, so if we take the mass of the solute, that was given to us, right? 25 grams. Okay, and then we divide it by the mass of the total solution. Okay, you have to be really careful, bless you, with the wording in these problems. Okay, the total solution is going to be your 25 plus the 87, right? It's not just the 87 because that's only accounting for the water. Okay, so you have to use the 87 plus the 25 times 100, and that gives you 22.3% by mass sodium chloride or salt solution here. Okay, if the problem was worded differently, and I think there's one on one of the homework somewhere, or one we'll do today, I can't remember. If it was worded differently and it said there's 25 grams of sodium chloride dissolved in a 100-gram solution, okay, then what do you think we would do? We take our 25 and we divide it by what? 100, right? Because it told us the total mass of the solution. Okay, so there's two ways that these can be asked. One, where you're given just the solvent, so you have to add them together. Or you could be told the total mass of the solution is 100 or whatever it could be, and then you just plug that number in here. Okay, but the idea is that it's the whole solution. It has to contain all of the parts of the solution. Okay, most of our formulas we can rearrange, right? So if we know one component, we can rearrange the formula and we can find the other. Okay, so here's an example where we want to find the mass of sodium hydroxide that we need. So this is very important. This is how much sodium hydroxide am I going to have to use to make this solution. Okay, so Miss Janice and I do this all the time. We have to come up, we want to make, our experiment calls for an 8% sodium hydroxide solution. Okay, and we have to make it. We have to make it 8% so the reaction will work. Okay, so what we do is this equation right here. All it is this rearranged. Okay, so if it's 8%, we need to take it out of that percentage, right? So we need to move our decimal place back. Okay, so there's the 8, so we need to move it back over here. Okay, to take it out of the percentage. Everybody see that? Okay, we're looking for the mass of NaOH. So how much NaOH am I going to have to measure out to make an 8% solution? And then it tells us that we have a 250 gram total solution that we're making. Okay, so then all we do is rearrange. You could have rearranged the equation before if you wanted to. It doesn't matter. Okay, you can rearrange it and then plug in. Then you're going to solve for grams. I'm going to have to multiply through by 250, right? Okay, so 250 times the 0.0800 gives us 20 grams of sodium hydroxide. This is another way you could do this. Okay, so we know that we have a 250 gram solution, and then we have 100 grams. Out of 100 grams, there's our percentage. We have 8 out of 100. Okay, so we looked at that when we were talking about purity, so that's kind of the same formula there. But this one, you just use your 8% is always 8 out of 100. And then you have the 250 there. So there's two ways to do this, but this one uses our new formula. Okay. This is the second most common unit, and actually the one we'll use the most, okay, because it's very useful to us in calculations. Okay, and we'll see that, and we'll try to do that. I guess it won't be next week, but the week after that. Okay, molarity. So this is common. So I will say that the solution is 2.0 molar or molarity. Okay, molarity and moles are not the same thing. Okay, so when you are writing these, if you want to abbreviate, if you want to write moles, some people will abbreviate with our lowercase and just write mole there, but not to be confused with molecule because they're all different. Okay, molarity is capital M. So I'll have it as capitalized and usually italicized also. Okay, molarity is equal to the moles of the solute, so that's what's present in the smallest amount, divided by the liters of the solution. Okay, so now we are plugging in liters here because we have a volume, right? We have a solution that we are working with. Okay. A millimole is 1/1000th of a mole. Okay, so don't let this confuse you. We'll go back to this and look at it. But if you're in milliliters, which is 1,000th of a liter, then you could say molarity is millimoles per milliliter. Okay, these are essentially the same. We're still finding molarity. This is just when you have larger quantities. And a millimole is a smaller quantity. So if you're working on a really small scale in a lab, which we don't do, okay, you would use millimoles. Okay. Okay. So if we want to calculate the molarity of a solution, okay, that is 12.5 grams of sulfuric acid and 1.75 liters of solution. So the first thing we have to know, and we'll be using this throughout the semester, is what's molarity. So we just said that on the previous slide. So molarity is equal to moles of the solute over liters of solution. Okay. All right, so we're given grams of sulfuric acid, and then it tells us that we're in a liter solution, so we don't even really know what I'm assuming this is probably an aqueous solution. It's probably sulfuric acid and water. Okay. If we need moles, can we just plug in 12.5 into our molarity equation? No, right? Grams and moles, so this is a common mistake, but grams and moles are not the same, right? So we have to convert, just like we've been doing for the past few weeks, we have to convert our grams to moles. So that's what's shown here. So here's our 12.5 grams sulfuric acid, so H2SO4. This is just abbreviated here. Okay. If you add up a sulfur atom, 4 oxygens and 2 hydrogens from the periodic table, you get about 98.1. So that's our molar mass there at the bottom. Okay, so grams cancel. We have moles, and we get 0.127 moles of sulfuric acid. Okay. So then we plug that moles into our equation, and we're told that we have a 1.75 liter solution in the problem, and so we just divide. Okay, so we take the 0.127 divided by 1.75, and we get a 0.0728 molarity solution. So to be more specific, it would be a sulfuric acid solution. Okay, so let's think about something. All of our equations we've been able to, okay, we've got three variables here. Everybody agree? We've got molarity, moles, and liters. Okay. If we know 2 of these, we can solve for the third one, right? Okay, it doesn't matter. This is our, our standard equation. Okay, but what's something, how could we rearrange this? What's one way we could rearrange to solve for, let's say, moles? What would our equation be? If we rearrange, so that means rearrange, okay, and we want to find moles. What's that rearrange to? It's just some algebra here. Okay, everybody agree? Molarity times liters. Okay, this right here, we're going to start real big. It's going to be super important to us later. Okay, we're not going to see it as much today. Okay, but it's going to be really important to us later. Okay, what about if we wanted to solve for liters and we knew moles and molarity? Okay. Okay. If y'all think molarity, moles or molarity over, which one? What's on top? Okay. This is what I think. Moles over. Okay. Everybody agree with that? Everybody agree with that? Okay. Oops. All right, we're going to see those in a second, so we'll check your answers to see if they were correct, if I can ever get off the screen here. Okay. Let's look here. All right, this is one. So at this point, we're going to see how many people we have in here. This thing is acting crazy on me, sorry. Okay. Oh, hang on. I don't know what's going on. It's freezing on me. Okay. All right, let me see how many people we have. 1, 2, 3, 16. Okay. We're going to get in groups of 6. So I'm just going to kind of, when I tell you your group, so you 6 right here. So y'all need to just kind of get a little bit closer, okay? So 1, 2, 5, 6 right here. 6, and then over here, Jared, 1, 2, 3, 4, 5, 6. And if y'all don't mind, I may have to scoot you over. So you 3 and you right here. Okay, Jonathan. Okay. And then this should be it, right? 1, 2, 3, 4, 5. So we're just one short. Yeah. So you 5, y'all may want to come right here and kind of get together. Okay. All right, we're going to have a series of problems that you all are going to work together as a group. Okay, these are going to be for bonus points on the exam. Okay, the group that gets the most correct, okay, is going to get bonus points. All right, you can still ask me questions because this is new. Okay, this is just the first one. Then we're going to talk just a few more minutes, and you'll do another problem. Okay, when you get your answer, your final answer, then you need to circle it, put it, make sure you use units. If there are units, be sure you do that, okay? Also watch your significant digits, Okay, I may not be quite that picky, but you need to think about it, okay? So everyone needs to be involved. You want to come up with the answer to the problems. I think there's going to be like 5 or so through the class. Okay, and then we'll answer them and see who got them correct. Okay, so we're going to have a grader, so I have to be somebody very honest that's going to grade your problems. Okay, so we may do them as we go. That way you can go ahead and see the answers. Okay, but here's the first one. So it says determine the mass of calcium nitrate required to prepare 3.50 liters of a 0.800 molarity, notice the big M there, of calcium nitrate. All right. So you're going to use the formula that we just talked about, but you want mass. Okay, so you've got about, I don't know, maybe 2 or 3 minutes here. So you need to work together, see what you come up with, and then somebody give a final answer on your paper. Okay? Do you already have your answer? Oh, yours. Okay. Okay. All right. So you may want to work, figure it out on your own, then talk about it. Okay, but we've got quite a few of these, so. Okay, just a couple more minutes and get you a final answer. First. Yes. Can't tell you the answer. Doesn't look. I think it's off a little bit.
What was your answer, Melissa? I got 2.84. That's what I got.
Okay, where are you getting that from?
The 0.8. Well, that's molarity.
Yeah.
That is molarity.
Okay, where's that coming from?
The 2.8.
How'd you get that number?
I multiply 3.5 to
I don't know what's going on from that point. off a little bit.
That was the molar mass solution.
Okay, what was your final answer? I forget. 350. That doesn't seem right, but everything's set up right. Hang on. Yeah, it's just your multiplication. Plug it back in your calculator. The last step. You're just not getting the right answer there. Okay. Watch your significant digits. Okay, let me see. Okay, watch your significant digits. Okay, yeah, but you rounded, so you rounded to 2. Got to round to 3. So it should be that. Well, no, because see, look, about 9. If you look at it next is a 4. Yeah. All right, let me see your answers. That may work the best. Is it below it? Okay, yeah, circle it. Okay, watch your significant digits. Okay, circle it. Okay, circle it. Okay. Give you about 20 seconds. Have I seen this group? Have I seen yours? Your answer? Okay, circle it and show me. Okay, watch your significant digits. We got about 10 seconds to fix it. Do y'all have an answer? Okay, watch your significant digits. Let me see. Yep. All right, y'all are last here. Let me see. There you go. There you go. All right, good deal. Everybody got it. Okay, you had to take, listen up, molarity times liters to get moles, right? And that was like 2.8, and then, or 2.80 technically. Then the molecular weight, or really formula weight of calcium nitrate was about 164.09. Okay, and so then you had to convert from moles to grams, and we do that by multiplying. Okay, and you get 459 as the answer. So if you didn't write it out yourself, be sure you do, because you're going to need to study it. Okay, so what you just did right here, this molarity times liters equals moles. This has to stick in your mind, even though we just saw all you did was rearrange, right? Okay, well, in our next unit, we're going to need this. Time in and time out. We're going to need to be able to take molarity of a solution times the liters to give us moles. Okay, in our sequence of grams to moles to grams, what's the first step? What are we doing? We're converting from what? Grams to moles. If we have a solid. Well, our first step in the next unit is going to be taking a solution and its molarity, instead of grams, because we have a solution, times the volume to give us moles. And then we can take moles and go to moles of another compound, right? And we can continue it out. Okay, so this is going to be really important. And here's the millimoles. So if we're in milliliters, then molarity times milliliters equals millimoles. And all it is a thousandth of a mole. It's just smaller, a lot smaller. Okay, we already discussed this. If you dilute a solution, okay, and this is just even our soft drinks. So they have syrup and sugar and whatnot, or if it's diet, it may be aspartame. You've got CO2 in your soft drinks as well. Okay, and they dilute this. Otherwise, they're going to dilute it with, usually water. Okay, and so this is going to make those soft drinks or sweet tea less sweet. Okay, we do the same thing in the lab. If something's too concentrated, especially for safety reasons or for our procedure, it calls for something less concentrated, we dilute it. And a lot of times that means we're going to add water. Okay, it doesn't have to be water all the time. It can be something else, but a lot of times it is. Okay, but think about this. If we have a salt solution, so let's say my cup here, I put some salt in there, right? And I don't know why I'd be drinking salt water, but let's just pretend that I like salt water. Okay, so if I drink this, or maybe I have a cold and I need to, I don't know, whatever. So, and it's about this much. Let's say it's probably about 15-20 grams of salt in there. Okay, and it's too salty. I can't quite take it. Okay, so what would I do to help me not taste the salt as much? Yeah, or add something else. Okay, or I could, so if I doubled the volume, so let's say I doubled my container here and still had that amount of our solute, or the salt at the bottom. Okay, the idea here is when you dilute a solution, what's changing? The amount of solute or solvent? Solvent, right? The solute, if I have 15 grams in here and then I double the water, do I still have 15 grams of salt? Exactly. Okay, so we can use a formula only when we have a dilution, when our moles or mass of our solute isn't changing. All we're doing simply is adding more water to make it less concentrated. Okay? So in red here, the number of moles, or the mass of the solute, is constant, right? All we're doing is just diluting it. We're adding more solvent to it. Okay, so we can do this little equation here, and M1V1 equals M2V2. Okay? And this is only appropriate for dilutions. It's not appropriate if you have a chemical reaction. Okay, and I have A plus B yields C plus D. Okay, I have different mole to mole ratios I have to think about. Okay, the concentration could be changing, so it doesn't work if you have a chemical equation and you're trying to do the relationship there. Okay, for M, big M stands for molarity. 1 stands for initial, whatever your initial molarity is. Okay, so you can put MI if you want to. Okay, volume 1, that's V. Okay, it can be in liters or milliliters. Okay, you just have to be consistent. Okay, if you're given 2 volumes and one's in milliliters and one's in liters, you have to make them the same. All right, so you could convert liters to milliliters or liters to milliliters. Doesn't matter what you do, you just have to keep them consistent. Okay, M2 is molarity final, so that's your resulting solution, and V2 is final volume. Okay, and this can be in milliliters or in liters. Okay, so what's molarity? Molarity is equal to moles over liters. Okay. All right, so if we have 10 milliliters of 12 molar HCl, that's pretty concentrated. 12 molar HCl is not something we would put out for our students to use. Okay, and we want to add it to enough water so that we have 100 milliliters of a solution. Okay, what is the concentration of the solution after we dilute it? All right, so if we look here, our M1, or excuse me, our V1 is 10 milliliters. That's our initial volume. Our M1 is 12. Okay, we're looking for concentration, right? So that's our M2, or you could say X. You're solving for X. Okay, and then 100 milliliters is our V2. Okay, then all you do is do the algebra. You isolate M2 by itself, and in order for you to do that, you're going to have to divide by 100 milliliters. So it's going to have to come over here. You have 12 times 10 divided by 100.0. There's 3 significant digits here, so we're going to have 3 here. So the resulting molarity concentration after you dilute it is 1.20. So that was a big dilution, right? We went from 12 molar, very concentrated, to 1.20 molarity, which is a lot less concentrated. That would be more like something we would have in the lab for y'all to use. Okay, this one is not part of your little assignments there because I already had the answer on the PowerPoint. So we'll just go through it together. So if we have a volume, or it says what volume of an 18 molar sulfuric acid is required to make 2.50 liters of a 2.40 molar sulfuric acid solution. Okay, so you got to go through and label your M1, M2, V1, and V2. Okay, so it wants to know what volume. Okay, so right here. Okay, so what volume, all right, of an 18 molar sulfuric acid or solution. Okay, so what is that 18 molar? Is that our M1 or our M2? Okay, okay, that's going to be our M1 because that's what we have. So it says what volume of an 18 molar sulfuric acid. So we have is required. So this is our M1. And this is what we're making. So this is going to be our V2 and our M2. Okay, so you just have to watch the wording here. Don't get it backwards. Okay, so if we use our M1 V1 equals M2 V2, we're looking for V1. We want to know what was the volume we needed to use to prepare this solution. Okay, so it's kind of just working backwards from what we did earlier. So if we move over, so you can rearrange before, or you can do it, you don't have to do this. You can go ahead and plug it in there if you want to. But 2.5 is our M2, or our V2. Our M2 is 2.4, and we divide it by the 18. Okay, that's what we started with. That was the molarity to begin with, so that makes sense because it's higher, right? It's 18 molar, which is very strong. Okay, and then we get 0.33, 3 liters, or 333 milliliters. Okay, does everybody see this? Okay, here's the extra practice. If you have these are going to be part of your group effort. All right, if you may need somebody, hopefully someone in your group has these printed out, okay, because there's 3 of them. There's 1, 2, 3. All right, so I'll leave this one up for a few minutes, but it might be helpful if you have the printouts because the 3 problems are on there. Okay, so these 3 are going to be added to the one that you already have. So everybody got the first one. Okay, so now you need to work through these 3. So I'll give you, maybe 10 minutes to do these, 10, 15 minutes. We'll see just kind of how everybody's progressing through it. Okay, we've used the percent by mass equation today, molarity, and our M1V1 equals M2V2. So these problems are going to be using those. Okay, so not necessarily in that order. Okay, like I said, if somebody has the printout, so be quick, or you need to copy down quickly. Because in about 2 minutes, I'm going to switch to the next one so you can get it as well. Alright, I did these a little out of order on accident, but here's the other one. That was actually supposed to be the first one. It just flipped on me. We all get bonus points. One person needs to have all of the answers on there because I'm probably going to take that from you or use it to add the bonus points. So. Okay, so go ahead and get this down if you don't already have it. This one requires you to be able to name. You take a name and write a formula. You're going to have to do this on the next exam. So sodium phosphate, you may need your polyatomic ion chart. Okay, y'all looking at me and staring. Very first beginning, we had to name. You had to take a name and make a formula. We spent the whole class doing that, and that whole long worksheet's all naming and writing formulas. So that's what you have to do for sodium phosphate. Does everybody have this written down? Okay, you've got this one. There's the last one. You get these three done. This worksheet we did Monday, and we had 4 and 5 left. Those are the last two. Okay. Okay, once you get these three done, the worksheet we did on Monday, these last two, 4 and 5 that we didn't get to, those are the last two that you want to work. The worksheet from Monday, the chapter 3 in class problems. We didn't get to 4 and 5. Those are the last two that you'll want to work after these three. So you're going to work these two as well, okay? After you finish these three, the last two that you're going to work are from the worksheet from Monday, number 4 and 5. Okay? Your worksheet from Monday, that looked like this, where we did the grams, smalls, moles to grams, and we didn't get to number 4 and 5. That's going to be the last two for today. So you're going to work these three up here, and then those two. Okay. you should have 6 problems. Okay. Now I need a sheet that doesn't have to necessarily have the problems worked out, but all 6 answers and the names of the people in your group. Okay, and then we'll go through them in a few minutes. Well, there's a couple things you can do, but first you've got to get your, got to use the density first would probably be the best way to start. Okay, density is grams per milliliter, right? Okay, so if you're given a percentage, what formula do you need to use, you think? Yeah, this is the hardest one, so I don't want to give too many hints, but this will be the problem that gets the winner probably. Okay, so you're going to, your percentage tells you what formula, but then you've got to use that density somehow, because in your formula you've got to have mass, right? So you're going to have to use that density to get the mass for that formula. For which one? For this one right here? Yep. You are. But okay. So the problem we have, right, is you've got to have grams here, right? Because you have mass and mass. Okay, you're given the percentage. Okay. You're looking for that, right? So that's your X. But you need that. But you're given volume, right? So you got to take that volume and that density and use that to find the mass. Is that the only one y'all have left up here? How many, do you know how far along y'all are? Okay, you haven't done the other two? Okay. How about y'all? How many do you have left? Do you know yet? Okay. Okay, once you come up with the answers, the part of the group is to talk through them. And you need one piece of paper that has all of your answers on there. So there should be 6 answers with units and correct significant digits. And all of your names on the piece of paper. Do it. Which one? Oh, number 4. Okay. How many significant digits do you need? Okay, let me see what you used up here. Okay, so you're... Yeah, that's fine. Yeah, I got 36.45 there. So... Yeah, so I would check that because it ends up rounding to this. Yeah. Yeah, but you just have the one significant one there, so you got to keep going. You got to have 3. So if yours didn't show anything, then that means it'd be 00. Yeah. On mine, it showed up as a 1, but that's fine. 00 is fine. Yeah. And then be sure you put your unit there. Mm-hmm. All right, 5 more minutes. In 5 minutes, I need 1 piece of paper, all your names on it, and 6 answers. First part of what you said is correct. The second part's not. You're Haley, right? Okay, don't forget about her because she knows the answers, so she just won't speak up. Have y'all gotten all the answers but one here? Got one left? Okay. Do you have them all worked, Haley? Just about, yeah. Well, you've been doing awesome on the test, so I know you. Y'all collaborating? Okay. Stuck on one question? Okay. So y'all all have to have 1 piece of paper with all your names. Y'all got it? Okay, and be sure you've looked at significant digits and make sure you have a unit if you need it, okay? Okay, don't forget about units and significant digits when you write down your answers. Okay, you should have a unit on everything, I'm pretty sure. Yep. You got your final answers? Okay. I can tell you no, but I can't tell you anything else. And then which number is that on your piece of paper? Is that number 4? Right, but that's number 4 on your, right. Okay, because I have mine different. Okay. Yep, but don't forget about significant digits and units. Okay, that wasn't the right significant digits on your calculator. Okay, I need one grader in the group. Okay. Connie, you're the grader. Okay. Get you out a pen. Okay. All right, class is not done yet here. All right, get a grader. Let's have Hannah, right? Okay, Hannah's going to be the grader. Okay, so take out a pen, Hannah. Haley's going to be y'all's grader, so wherever your piece of paper is, if she'll get out a pen. Okay. Lindsay is going to be y'all's grader. Get out a pen. And let's do Fraser. You're going to be the grader for you guys, okay? Okay, before we grade these, reminders. Homework is due on OWL by 9:30 a.m. Monday morning. Okay. What else can you bring to class to turn in? The extra credit. Can you turn in one sheet of the extra credit, or do you have to turn in it all to get the points? I have to turn in all of it. So there's, I don't remember off the top of my head, but I think so. Yeah, I know there's the long naming, the chapter 2 and 3 worksheet. And then we've done the in-class problems, right? So those won't be part of it, but I'm pretty sure there's just 3. Okay, we will go over these problems because some of you may have missed them. We'll go over these on Monday, and we'll also do a practice test. Okay, so that will hopefully get you ready. But saying that, the practice test won't have everything on it. Okay, it's just for, practice purposes mainly of the calculations. All right, so graders, you ready? All right, number 1, I already went around and checked this one. Okay. 459 grams. G has to be afterwards. Everybody got that? 459 grams. I checked everybody's. Okay, these numbers might be slightly off. If they are, let me check it because you might have used a different periodic table than I did. All right, number 2. Should be 0.250 liters HCl. Well, let's look back at the problem. Okay, it's wrong. Okay, everybody listening? Is everybody listening? All right, it has to be 0.250 liters, technically HCl. Okay, there are 3 significant digits here. So you have to have 3 in the answer. Everybody got it? If it's not 3, you mark it wrong. Okay? Graders, y'all got it? Okay. You got it back there, Fraser? Okay. Y'all graded it? Okay. Number 3, 0.866 molarity. Big M. Didn't get it? Okay. That's okay. Did y'all get it? You got it, Haley? What was it? That's still wrong. It's too far off. I'll have to look at it. That's fine. You can count that. Job 0.866. Okay, way off. Okay. Yeah, I'll have to look at that. It may be more than just a rounding thing. Okay. All right. Number 4, the one that gave some trouble, I think. Okay. We'll go over these, like I said, Monday. 85.1 grams. That was the hardest one. Y'all got it? Okay, 85.1 grams. 5.1 grams. Okay, any questions on what your answer was versus somebody else? Fraser, you got it back there? Okay. Put a big X if you got it wrong. Okay, number 5. Okay, this one might be different slightly, okay, because I already saw some that were. 0.0501 molarity. Did you get it right? Anywhere close? 0.005? Okay, did y'all get it right? Okay. Do you have a question about yours? What'd you put? No, you had to have 3 significant digits. Hey, what about over here? That's 2. Okay, so it's wrong. All right, Fraser, you got it back there? Did y'all have 3 significant digits? Okay. All right, number 6 is, we found V2, and it was 300 decimal place milliliters, because you needed 3 significant digits. Okay. Any questions on that one? Okay. What I want you to write at the top, make it big, at the top of that piece of paper, write the number that you got correct out of the 6. So if you got 2, put a big 2 up there. It's wrong. Yep. These are for bonus points. The last answer was 300 decimal. Good. All right. Write the number you got. So how many did you get correct, Connie? How many did y'all get? You got 3? All right. So put you a big old 3 up there. Okay? All right. Next. Where's yours? How many did you get? 2. Good deal. Okay? Yes. Number 3 was 0.866. I think I told you I may have to check that one. Or no, you put 868? That's fine. 85.1 grams. Number 5 is 0.0501 molarity. And 300 decimal milliliters. Okay, got yours. How many did y'all get? Okay, and that's including if... Okay, where's your work on that one? I'll come back to y'all in just a second. All right, did I get yours? All right, how many did y'all get? Okay, good deal. Everybody gets bonus points. Yay! How many ever you got on this? Okay, so it wasn't just the winner. All right, y'all have a good weekend.
Numbers that mixed up on here. This one's actually number 5, and we just missed number 4.
Oh.
Number 6.
Okay.
And we just missed number 4.
Okay, so you got 4.
Yeah, we got 4 of them, correct.
Okay, thank you. All right, and whoever has the work for this one, let me check y'all's. Yes. Okay, it's a sort of a pain for Janice to have to set everything up, and then we have different labs running all the time. So we'll just need to go talk to her. I don't know that she may be here today. She's just in the lab, so you can go talk to her. Or I can give you her number to call and set up a makeup time. So, okay, let me write her number down in just a second for you. Hang on, sorry. Let me get my page. It's easier for me to look at my work here. Okay, 355 grams. Okay. Yep. Okay, the problem is that's wrong. It should be where is it? 163.94. Okay. So somewhere, yeah. Okay, let me. Okay, so y'all got 3 instead of 4, right? Okay. It's giving you trouble? Okay. Okay. Okay, got it. Are you feeling better?
A little bit.
I hope you feel better. Okay. Of the the problems.
No. But I have the physical copy of the textbook. It's like I can't get the page numbers because Owl's.
Okay. The questions on OWL are not in your textbook, if that's what you're asking. Yeah, they're their own things that they come up with. And what did you say is giving you trouble about it?
It's basically saying that my time has expired on it.
Okay, so you chose the option of the 2 week. Okay, where'd you get your book from?
I got it from the Calhoun bookstore.
Okay, it should have come. There's her number. Let me. What do you need something? Okay. I will give you this. The compounds you need to know are on the Chapter 2 key terms handout. Yeah, and they're underlined, the ones you need to know. Let me stop recording so we're not.